Welcome back. In this video, we will learn how to take inputs from users in Python and how to safely convert that input into numbers. This is one of the most important skills for real programs because users always enter text and you must convert it to the correct type. If you want your Python scripts to be interactive and useful, this lesson is essential. So Python has this built-in function called input that allows your program to pause and wait for the user to type something from the keyboard. So whatever the user types is returned as text, a string. So let's look at an example code here that I have. So here when this code runs in the VS Code or any IDE, you can see that it prompts, so it prints a message, enter your name. So it shows on the screen, and when the user types his name is her or her name and presses enter, so Python takes that text and stores it in the variable name and then prints the greeting with the user's name. So whatever name you entered is a string captured here, and then it concatenates and prints that name as output. So here is an important thing to learn. The input always returns a string. Even if the user types a number, for example, Python still treats that as text. So let's see an example. So I have another code where it takes the input as the age of the user. So let's run this program, and when I type the age as 20 and then press the enter key, so you see that the output of age is class. That will show the type of the age is class string. This means that Python thinks that the number 20 is actually a text and not a number. If we try to add a number to it, we will get an error. So suppose, let's say I'm going to take the input and then add 5, for example, and let's see what happens now. So let's say I have 20, and then you can see here that it cannot add because the age is not a number, because in Python the input always takes the value entered and stores it as a string. So that's why we see this type error, and it says it can only concatenate string and not int. So there you go. To fix this, what should we do? We must convert the text into real number type. So Python has two main conversion functions for this. One is the int method and another is the float. The int is used to convert to whole integers, and float to convert the string input to decimal numbers. In general, int when you want to convert to whole integers and float to convert to decimal numbers. So here is how int is used. The int method example code is here, and you can see now Python understands that the input is an age, because we have used the int method to convert the input, which is a string, and then we convert the string into an int number, integer, and store this as age. So this integer now can be used for mathematical calculations without any problem. So let's run this program and see. Let's say the user enters the age as 30, and Python will output the correct result. So you can see the input always accepts the user input as 30, which is a string, and then we convert that string to integer using the int method, and then the converted integer is converted. The input is now an integer, converted value is a pure integer. So now you can see that 30 plus 5 is 35. So this is very useful. So another scenario is we can also convert to a floating point number. So let's see that code example. So here I have the program that will accept the input price of an item. Say for example, this is when you want to enter money measurements or any averages. So let's run this program and see. So we have this prompt here, enter the price, and this input is actually a string, but now let's say 2, and you can see the input is always a string, so the 2 string comes here, and then we use the float method here to convert that 2 into a float. and now the float number is now stored in this price variable, and then you can see the 2 times 1.1 and the price with tax is 2.2. So this is useful when you want to program, when you have a program that deals with money, measurements, or any decimal numbers or floating point numbers. And one real problem beginners face is what happens if the user types something that is not a number. For example, user might type characters or letters instead of digits, and what will happen in that case? So let's say we have a program where we saw the number, the input being converted into integer. So let's say instead of a number, I'm going to type let's say XYZ. So this is a string. So let's see what happens. So this XYZ string, when we use the int method to convert that input string, we see an error, value error. So this code actually tried to convert this int method in the code, tried to convert that the input to an integer, and it failed. So it will print a friendly message instead of crashing. So this is how we build. This doesn't build a. It didn't throw a friendly message actually. So you have to write your program using the try except structure. So this makes the program to print any error messages or anything that happens in the program to be handled safely and more user friendly. So let's update the code and see how it works. So here we have a code, the same code, and here when the user tries to enter a string, and this int method, when it tries to convert that string, for example ABC, to a number, it's going to crash. It crashed before in the previous example, but we don't want to see this ugly message. So whenever this message, so what this try except is that if this line fails to convert, as in this case we saw when we tried to convert the string to an integer, it failed. So we are going to catch that error and then handle it safely and print a user-friendly message. So whenever the program fails, it's going to jump to this value error, which is the expected error message we got here. So we are going to catch that value error and then print this friendly message instead of this default traceback error or the stack trace that's not user friendly. So let's run this program and see the output. So you can see, let's say instead of a number, which is an age, I'm going to type something like Z, and you can see we didn't get that weird non-friendly, not user-friendly message, but here we get a user-friendly message because something happened here, the program failed, and we know what error it's going to throw. It's going to throw a value error. So you caught that value error except. So that's where you provide the actual specific error and then the class name of the error you can see here, and then the code, the logic, the flow enters. Now the code runs this print command, the print message that says that is not a valid number, please try again. So that's one thing, and so this is a very useful structure that you should use in the program to print a friendly message instead of letting it crash. So this is how we build safe input systems. So when the user tries to enter something that is not expected, any unexpected value, we need to make sure that we print a friendly message so the user can understand and fix the error the next time he runs the program. So now if we enter a number, it's going to run fine. So the user knows that what mistake he did, so it's more useful to the user instead of printing a unknown, non-understandable trace message. And let's also see another thing. We can also check before converting using the isDigit method. Let's look at an example there. So here we have a program, and what it does, it takes the number from the user input and then checks whether the number is a digit. We are not going to convert that number blindly. We are not just going to call this int method. We are going to first check whether the A number is a digit. If the number is a digit, there is no need to call this int method. So that's why we have the if condition. So if the number is a digit, only then we call the int method conversion, and we print that the number is this. If the number is not a digit, let's say the user enters ABC, then it's going to come to the else part and return, because it returns false. This is digit going to return false, and the user enters a string, so it's going to print invalid input. So let's run this program. So you can see when the user inputs a z or some string, so this is digit is going to return true, is going to return false, so it's going to print invalid number, not a number. And when I run the program and enter a valid number, it's going to be true. This digit is going to return true, and we are going to print this number is 10. And another useful conversion is turning numbers into text again. Here we saw the text is converted to number using the int. We can do the other way too. So let's take a look at an example code. So here, let's clear the output terminal. And here I have a score as 95, and when we are going to concatenate this 95 with a string message, your score plus what is the actual score. So when we we cannot concatenate string and number, so it's going to throw an error. So we use the str method. This str method converts numbers into text. So when we run this program, it's going to run fine. Without this string, it's going to print an error that it cannot mix both string and integer. So let's run this program and see, and you will get this type error. And that says can only concatenate string, not int. So that's why when we use this str method, so you get the string here, the 95 converted to string. So it's basically what it's going to do is it's same as this. So the 95, it's going to imagine this is a string here with double quotes. So that's what is happening here. And when we run the program, it works fine. So that allowed us to join it with any other text that we see in this example program. So before we finish, let's build a small real example that combines all of these ideas. And let's say, suppose we want to ask the user for two numbers and print their sum. So I have this sample complete code here. So you can see we ask the user for the first number and the second number, and we store the input entered by the user, and you can see here the float method converts the input string in both cases into a floating point number, and these two floating point numbers are stored in a result, and we print the sum. And if the user tries to enter a string other than a number, we know exactly what error is going to get. So if in this case we know it's going to throw this value error class, and we are going to print the friendly message instead of a complicated stack trace or other default error message from Python. So let's run this program, and let's see a happy path. So here the age is a number, first number is 10, second number is 20, and we converted that into a floating point number, and then we printed the sum successfully. So it works with whole numbers as well as decimal point numbers. So even if you type a floating point number, it's still going to work. And when you type accidentally an X, and it immediately says one of the entries was not a number, it didn't even wait for the second input, because as soon as the program fails, it fails fast. So it doesn't go even to this line, so it's crashing here with a value error, and we catch that value error here and print it. This try catch, if you are familiar with Java, it's the same, like try a few code. If it fails, then you catch it and then handle it with your own personal message. So it's similar to Java try catch, but in Python we use the try, colon, and except value. But the main point of this video is you can use these methods to do these conversions. So let's review the key steps. So input always returns text, and you can use int method to convert the string to whole numbers, and you can also use the float to convert to decimal numbers, and use the str method to convert numbers back to text. And always try to use the try except or checks like isDigit to make sure you check these things, the inputs of the user, to prevent any errors. So once you understand these ideas, your Python programs becomes much more powerful and interactive. So please practice these examples in VS Code or IntelliJ or any IDE, your favorite IDE. Try entering different values, including letters and numbers, to see how Python responds. In the next video, we will take a look at the Boolean and comparison operators, which is the next section of the logic and control flow in Python. Thank you for watching, and if you like, subscribe to this channel for more videos on this Python and other QA and dev topics.